Today we'll be looking at histograms, part of your higher paper here. People always struggle with these. They are quite fiddly and quite difficult to kind of get your head round, but the idea basically, we've got some data up here about some weights of some apples. Now we use a histogram when we've got unequal class widths. So remember how you divide your data up into groups. Here the widths aren't the same, so between 30 and 50, so that's 20 wide, there were 18 apples. Between 50 and 60, there were 28 apples, etc, etc, reading down. So that class width is 20, these are 10, and your last one down here is actually 30. So what we need to do is put this information on a graph. We're going to plot frequency density. This is about the area of the bar. Because the widths are unequal, we're going to look at how the areas of the bars themselves compare to each other. So we're going to plot frequency density across your weight of apples along the bottom there. The frequency density is going to go from 0 to 4, so when you're making your calculation, if you're getting numbers bigger than 4, you've probably gone wrong somewhere, because it won't fit on the graph. Now another thing just to draw your attention is a little squiggle here. It just means that this end of the graph isn't going to be blank, because our data starts at 30. So we do a little squiggle there, which means we've chopped out a lot of our empty graph. Okay, so frequency density outside, and the weights along the bottom. How are we going to actually work this out? Well, we've got a frequency and we've got a class width. So what we do quite simply is we divide our frequency by how wide the class width is. If you remember from your area, it's length times width. So I've done the sums here. 18 divided by 20 gives me 0.9, so this frequency will come up 0.9. 28 divided by 10 is 2.8, notice the class width is different. 36 divided by the class width of 10 gives me 3.6, then 0.75, and finally 3 little apples between 90 and 120 grams. Gives me 0.1. You'll notice my highest value is 3.6, which fits nicely onto my graph, so we're all in the right areas. Now what I have to do is put this on. So I'm going to put my first bar is between 30 and 50 and has a height of 0.9 frequency density. So there's a little bar there. In your actual exam you're given half a square room for error, margin of error, so we need to get this done accurately, sharp pencils, etc. So I've come up to 0.9, there are 10 squares between 0 and 1, so each square is 0.1, come up 9, and the class width is 20 there, as it is in my example there. And there's the rest of them. So I've come in here, between 50 and 60, my frequency density was 2.8, so I come up 2 little squares below the 3, and a width of 10. Same here, width of 10, but my frequency density is now 3.6, comes all the way up here, just 1 over halfway there, gives you 3.6. Again here, it's 20 wide, 70 to 90, my frequency density is 0.75, so that's half a square in there, you can see that. You're given that leeway there. And then the last one, between 90 and 120, class width is 30, and my frequency density is a mere 0.1. Kind of reflects that there weren't very many apples in that weight range, yeah? So there it is there. Class widths are the same in here, your frequency density goes up, all fits nicely on your bar.